Good day, everyone, and welcome to Math Lesson Online, brought to you by Expert Education Center. My name is Peter Ohwe. Today, we shall be looking at set theory. A set can be defined as a list of items that have features in common, such that the members of the set are distinct or unique. A set is always represented by curly brackets. We take an example. The set B, which is equal to 2, 3, 5, 7, 11, and 13, is an infinite set of prime numbers, while the set C, consisting of A, E, I, O, and U as members, is a set of vowels. Notice that B is an infinite set, while C is a finite set. Let's talk about types of sets. The first type of set is the empty set, otherwise known as the null set. This is a set that has no element, as shown in our example D, consisting of the curly braces without an element in it. Next is the universal set. This set contains all possible elements, written as mu. And as we mentioned earlier, we have the finite set and the infinite set. A finite set is a set that contains an exact number of items. For instance, the English alphabet consists of 26 letters, which makes it finite. On the other hand, an infinite set is one that has no boundaries. The number of elements in an infinite set cannot be specified, such as the set of perfect squares, given as y is equal to 1, 4, 9, 16, 25, 36, 49. Note that the perfect square is a number whose square root is a whole number. For instance, the square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. And you can guess what the others are. As a quick exercise, you can go ahead and pause the video and then add the next 5 items after 49. All right. Now we want to talk about subsets. Subsets are sets derived from the universal set. They are smaller than the universal set. The cardinality of a set refers to the number of elements present in a set. Let's look at some examples. If a set has one element, such as the set Z that has the element 5, then that set will have a cardinality of 2, as shown in our example. The two subsets will be the empty set and then the set that consists of the element 5. On the other hand, if a set has 2 elements, then the cardinality will be 4. For example, the set W consists of the elements D and F. Therefore, the possible subsets will be number 1, the empty set. The next will be the set that consists of the item D. The next one will be one that has item F. And the fourth will be the set that has the item D and F. As a general rule, using the formula 2 raised to power n, where n is the number of elements in the set, helps us to get the total number of subsets possible. For example, given the set M containing elements S, E, and T, we see that when you raise 2 to the power of 3, you get 8 subsets. And these subsets are 1, the empty set, then 2, 3, and 4, the set consisting of just one element, S, E, and T respectively in this example. And then the next 3 containing 2 elements, S and E for the first, E and T for the second, S and T for the third, and finally our 8th set containing elements S, E, and T. A quick quiz for you here. How many subsets do you think we can derive from the set K containing elements M, A, T, and H? Right, 16 possible subsets. Lastly, today, we want to consider the complement of a set. The complement of the set is that set that contains items or objects that are not found in the particular set, but are found in the universal set. The Venn diagram below will help us a great deal to understand this concept of complement of a set. If we consider the Venn diagram, which is represented by the rectangle, and then the two circles that overlap as our subset, it is possible for us to determine the elements that are found in A, the elements found in B, and then we can go ahead and find the elements not in A, which refers to the complement of the set A, and the elements not in B, which refers to the elements in B complement. In the demonstration, the elements in A are A, C, and F. Look at the region that is colored differently. The elements in B are C, D, E, and G. But notice that the C occupies the position where both sets overlap. In our next lecture, we'll be considering union of sets, intersection of sets, so that we'll be able to understand Venn diagrams better. However, elements in A complement are those elements that are outside the circle representing A. So if you take away the portion that is colored differently, you'll be left with the elements B, D, E, G, and H. Find the elements that are not in B, shown as B complement, are elements A, B, F, and H. Thank you for listening. Looking forward to our next lecture. God bless.